What's up, guys? I'm Mr. Lanigan. This is Easy Mode Math, and for my students, we are starting a new interactive notebook today, notebook number 5, and we will be breaking into a brand new unit. We're going to be talking in this is my third unit here, and we are going to be talking about systems of equations. In this unit, we are going to review what a system of equations is, how to find the solution. We're going to review how to solve systems of equations by graphing, elimination, and substitution, as well as systems of inequalities and how those relate as well. So if you are interested in these topics, make sure you tune back in for future videos. But in this video, we're going to focus on what is a system of equations and how do you solve it by graphing. What is a system of equations? It is two or more equations that share variables. So a system of equations is just more than one equation. I think a lot of times we get caught up in this word system, and that's confusing, but really it's just more than one equation. So in this first example, we're going to take a look at two different equations, y equals 2x minus 3 and y equals negative 2x minus 3. If I start with this first one here, in order to graph it, I'm going to start with the y-intercept, which in this problem, my b, if you will, is negative 3. The point that goes along with that is 0, negative 3, so it'll go right there. In order to find the next point on here, I'm going to use the slope, which is 2, and I can always write that as a fraction, so 2 over 1. And I'm going to go up to right 1. You could also go left 1 up 2, and that's how I've labeled it here. But either way you want to do it will get you to that next point. And then I just go ahead and I draw a line to it. Sometimes your teachers will ask you to find another point on the line, in which case you will use that slope again, going up 2 over 1 and find another point on the line. My apologies for not being able to center that correctly. And we could continue that or go the opposite direction, go down 2 left 1, or we could find many more points on the line as well by continuing to use our slope repeatedly. Now let's go ahead and graph the second line. Well, guess what? We're going to be starting from that same exact point, 0, negative 3, but in this case, we're going to go down 2 and right 1 because my slope is negative. And then we'll go ahead and draw the line through it. It's as easy as that, all right? We can add some more points on this line as well by using that slope. And now we need to really talk about what is the solution to the system of equations, right? So that is what the system of equations is, as well as some information about it. But if we take a look at this example here and clean it up a little bit, we want to really understand what the solution of a system of equations is, okay? It's easy. It's just the point where they cross. So right there in the middle of those two lines, boom, it's right there. So the point 0, negative 3 is the answer or solution to this system of equations. And we always want to write it as a point. Pro tip, if the equations or the functions have the same y-intercept, that will be the solution. In this case, they both had the y-intercept of 0, negative 3, so that point is going to be my solution, which is pretty cool. And you can notice that in the equations themselves, okay? Okay, so let's go ahead and take a look at an easy example solving the following system of equations by graphing. So I should be looking at y equals 3x plus 2 and y equals negative 1/4 x plus 2. So here are my options. I have 4 different graphs, and I want to figure out which one is these two equations. Which graph contains these two and will also show me my solution. So go ahead and pause the video, or on Edpuzzle it will be paused right here. And then pick which one will be for these two equations. Now an easy way to notice this again is that same y-intercept. But you could go through and graph each of these and then match it up. So if you picked, that's right, B, that would be the graph of those two equations, okay? What if we just want the solution to each of those choices from the first example? So if I take a look at these graphs, there are lots of points we can use, even if they're not drawn in. And this is something that confuses students every year for me. So they don't know what points they're allowed to use, they don't see any points on there, but remember, on every line there's an infinite number of points, and on every line there are points that are easy to graph. Like this point here, 3, 3 would definitely fall on this line, and we could put those points in there. We could draw them in, okay? So if we go ahead and we put some points in here for you to see, this is basically how it was in the previous slide, okay? Now, what we want to do is we want to go through and we want to identify what are the solutions to these four. So I'm going to pause right here, and you guys are going to write down the answer to all four of these systems. Okay, so in A, the solution to this system would be the point 0, 2. In B, the solution would be the point 0, 2 as well. Lots of equations have the same solution. That's how it works out. Wherever they cross, that's going to be the solution, and we can have the same answer. It's okay. In this one, however, it's going to be a little different. The point 4, 1 is going to be our solution, and in D would be the point -2, -1. Pretty cool. Every problem can't be that easy though, right, Mr. Lanigan? I mean, sure, there's going to be some trickiness, but we'll tell you about that as well. We have these two equations here, y equals 2x plus 3 and y equals 2x minus 7. So if I go ahead and I graph that first one, starting at 0, 3, going up 2 over 1, and then drawing my line through it. On the next one, starting at 0, -7, again going up 2 and over 1. Right there. Wait, they don't cross. So what's the solution then if they don't cross? There is none. There is no solution. If they don't cross, there's no point in common, and there will be no solution. It's not bad, right? So you're going to write down for your answer, no solution, okay? Wrap up. Any parallel lines, those two lines that don't cross, remember? Let's wait a second. Any parallel lines will have no solution. Okay, so that's a good one to remember. A lot of times we call this a special case. Are there any other weird things that can happen? Thank you for asking. Yes, there are. So let's take a look at these two equations here, and we have a little bit of a strange layout. Normally, an equation like this you would simplify, but oftentimes we are doing math in order to simplify them, and this would be one step in that process. Either way, we can go ahead and graph here, starting at 0, 3, and then a common question I get is, what is the slope when there's no number there? So as a reminder, we have a ninja hidden 1 here, and our slope in this problem would be -1 over +1. And to get to that second point, that would be down 1, right 1. Draw your line. Now, we're going to start at that same point again, and it's on the same line. But that's okay. It does happen. So no big deal there, okay? So we'll move on to the next point. And that's weird. That point is also on the line. Down 3 over 3. That one's on the same line too. So what's the solution? As it turns out, that point is a solution because it's on the line. But so is that one. So is this one that's unlabeled. All the points are solutions because they're the same line. There ends up being an infinite number of solutions when we have, there are two lines that are really the same line. And this doesn't happen that often. but it does come up, okay? So those would be our two special cases. So to wrap up our solutions to systems of equations, we can have one solution, and that's where those two lines cross nicely at one point. We can have no solution, where the lines are parallel and they don't have a point in common. We can have infinite solutions, where they end up being the same line. So how do you tell? Okay, one solution is going to have different slope and a different y-intercept if you're looking at the equations. Okay, no solution is going to have the same slope every time, but they will have a different y-intercept. And then infinite solutions will have the same for both if it's simplified. Okay? And that will do it for today, guys. Solutions to systems of equations. These are the situations that can come up. Most of the time we're dealing with one solution, but we do have these other special cases as well. And that's how you solve systems of equations by graphing. Pretty easy. It helps give you some extra practice for graphing lines, and it's not that hard. So let me know what questions you have, and for my students, please update your notebooks. Thank you guys so much for watching. I'm Mr. Lanigan. This is Easy Mode Math, and you guys have a great day.